You are asked to determine the relative humidity of air in laboratory by measuring the dew point, right? Another popular experiment we have, right? Another popular experiment we have, and this is the only experiment we have to find. We have to find dew point, right? Humidity. Dew point experiment. This is the only one, right? You are asked to determine the relative humidity of air in the laboratory by measuring the dew point. You are provided a copper calorimeter with polished outer surface, a thermometer, water, a sufficient amount of small pieces of ice. They are called ice chips. Small pieces of ice and a transparent glass plate. Okay. An incomplete experimental setup that can be arranged for this purpose is shown in figure 1. Right. Part A. In order to perform the experiment, you have to pour water into the calorimeter. Right. Out of the 3 levels A, B, C shown in figure 1, select the most appropriate level. Right. A is less. Right. Now for this one also we are filling it up to 2H over 3, usually 2H over 3, right? Or it can be a little bit below 2H over 3, right? Should be more than half. And C is too high because we are going to dissolve ice. We are going to dissolve ice inside this. When ice is dissolved, otherwise it can be spill out if that was too high, right? And A is like too low, right? Then if the amount of water is not enough to dissolve ice, again we have to do it for a very longer period of time. So appropriate level is B. Appropriate level is B. Right? Usually again 2H over 3 from the calorimeter. Right. B. 3 thermometers PQ and R having temperature scale ranges -10 to 50, -10 to 100, and -10 to 200, and -10 to 200 respectively are available in the laboratory. Select the most appropriate thermometer for the experiment. Right. So what we are going to measure in the experiment are only 2 temperatures. When dew forming starts, or when depositing dew starts, and when dew disappears. Only 2 temperatures, no? Right? Those temperatures are around, right? We know usually dew point in Sri Lanka is around like 23, 24, 25, 26, somewhere like that, right? So we don't need that high ranges up to 100, 200, no need, right? We don't need that unnecessary range because then percentage errors in your readings are very high. Then from these 3 thermometers, the best one to go with is -10 to 50. From these 3, the best one to go with is -10 to 50. That is -10 to 50 means P, right? Right? P with range -10 to 50. P with range -10 to 50. Give the reason for your selection. Right. The reason is asked. Give the reason for your selection. Right. So we know if we go with a longer, lengthier thermometer, when you measure small temperature using a long thermometer, right, percentage errors are higher. Right. Percentage error of the temperature measurement is higher. Right. That's the thing. Right. Percentage errors are higher because their least count is higher. Least count is higher. Right. Give the reason. Percentage errors in measuring temperature is higher. Right? Percentage errors are higher. C. What is the other important item necessary to perform the experiment which is not given? Right. Stirrer is not given, no? We need a stirrer, and when ice chips are dissolved, right? When ice chips are melted, right? You know, ice is always floating in water. If it floats at the surface, right? If it floats at the surface, it is going to do an error. It is going to make an error. Then for this experiment specifically, we need a net stirrer, or we call a stirrer with mesh. A net stirrer, very important. A net stirrer, net is important, right? Or you can say a stirrer with mesh. Or stirrer with mesh. Both are fine. Right, both terms are fine. Both terms are fine. D. In order to determine the dew point, you have to measure two temperatures. Yes, because we are getting the average of two temperatures when forming dew starts and when dew disappears. Write down the experimental steps that you would follow to measure the first temperature accurately with the observation that you notice. Right. Experimental steps. Right. Experimental steps. Steps are right. We have to add ice pieces, ice chips one by one. Right. One piece is added once and have to dissolve it and dissolve it. Right. Dissolve it means you have to stir it until it is completely dissolved. We have to stir well until ice is completely dissolved. While observing the surface of calorimeter, right? With the tarnishing starts. Uh, tarnishing means that shining disappears when forming dew starts. That is called tarnishing. That is called tarnishing, right? Then experimental steps, right? Steps are add ice pieces one by one. Add ice pieces one by one and well stir or stir the system well. Stir the system well. Stir the system well until tarnishing until tarnishing of uh, calorimeter, tarnishing of surface of calorimeter, surface of calorimeter begins, right? Then follow the steps to measure the temperature, right? Then we have to take the measurement at this point. External steps, right? Then steps වෙනම observation එක වෙනම අහලා තියෙනනේ. Then this is the observation no. Observation එක වෙනම ලියන්න ඕනේ. Sorry. Observation should be written separately. Then steps are adding ice pieces one by one and stir the system well. Stir the system well, right? මේක තමයි මේ step එක වෙනම ලියන්න ඕනේ. Step should be separated because that is separately as I didn't see the observation is given separately no. Right? Then stir the system well until ice is dissolved. Until ice is dissolved. Then the observation is the beginning of tarnishing, right? The beginning of tarnishing, where the tarnishing disappears, tarnishing starts and the shine disappears. Observation, beginning of tarnishing surface. Beginning of tarnishing surface. Beginning of tarnishing surface of calorimeter. Beginning of tarnishing surface of calorimeter. Right. E. In order to measure the second temperature accurately, write down the experimental steps that you would follow with the observation. Right. Again, the same thing. Right. First thing, you have to stop adding ice because then what we do is once the beginning of the tarnishing is identified, right, then we don't add more ice, right? We don't add more ice. So what we do is we'll stop adding ice. And then let the system cool down again and observing the surface again until the shine returns. Shine appears again. Right? So when the shine appears back, I have to take the reading again. Right? So when we do the experiment, another what we call a precaution we take is we are having two identical calorimeters. Then easily we can compare the shine of the surface of one calorimeter with the other one, right? With the empty one, right? එහෙමත් අපි පොඩි precaution එකක් කරනවා. Right, experimental steps. First thing is stop adding ice. stop adding ice, and stir well, and stir well, and stir well. That's enough. Observation and stir well, and stir well. Observation is the beginning of beginning of sign of surface, beginning of sign of surface of calorimeter, right? Observation is the beginning of sign of calorimeter surface, sign of the calorimeter surface, right? Then again, how to take the reading at that point. F, write down disadvantage of using water at 0 instead of ice pieces to perform the experiment, right? So that's a small thinking part. So in the guide given, we don't have such points given, right? They are thinking parts. If water is added, right, what happens is water is just going to increase its temperature, right? Water is just going to increase its temperature, right? Increase its temperature without no any state change. Then what happens is we'll need a large volume of water. State change එකකට යන්නේ නැති. ඒ කියන්නේ state change එකේ heat එක ටිකක් considerable heat යන්නේ. Change state change heat due to state change is a considerable amount, right? ml is a considerable amount because L of ice is 3 times 10 to the power 5. L of ice, that's a huge value. L of ice is 3 times 10 to the power 5, right? Whereas specific heat capacity of water is 4200. Compared to 4200, 3 times 10 to the power 5 is a huge value, right? So therefore, by a small amount of ice, right, we can let it absorb, let the water in the calorimeter absorb more heat, right? Otherwise, if we are to use water, we'll have to use more water, more volume of water, and sometimes it might get spill off from the calorimeter when water is used, right? Write down a disadvantage. Then the thing is, we have to have more water, more volume of water in that case, right? Then more volume of water is needed uh, to cool down until dew point, and it might spill out from calorimeter if volume is too high. Right? So I wrote a complete answer, right? Even if you have written more volume of water is needed, or water will spill out, right? Or the calorimeter will be entirely filled before the system reaches dew point. That's also acceptable, right? Right? Next, G. Give two errors that can occur if the experiment, if the transparent glass plate is not used in the experiment. Assume that a mask O and a face shield is not used, right? Listen. So we know that glass sheet is used to stop exhaling air reaching the calorimeter, right? That's the purpose, no? Stop exhaling air reaching the calorimeter, because if it reached, what happens is temperature around calorimeter can be different, because exhaled air is heated particles. Exhaled air means they are heated. Exhaled air is heated. They are heated particles. Since they are heated particles, then temperature around the calorimeter can be different. Right? And when exhaled air reaches the calorimeter, exhaled air can also be condensed at the surface. right? Because the surface of the container is cooled down now, right? When the surface of the container is cooled, right, even the water vapor that we have in our exhale layer can be condensed, right? Then one is temperature around the walls of calorimeter. Temperature around the walls of calorimeter, right, can be changed. Can be changed. And the second one is we have water vapor in our exhale layer, right? Then if it is condensed, again, uh, condensed water vapor is going to absorb heat when it dissolves, then going to have an error, right? Water vapor in exhale layer. Water vapor in exhale air can be condensed. Can be condensed at the surface of calorimeter. At the surface of calorimeter, right? Next, if three glass plates LM and N with dimensions of 5 by 5, 20 by 20, and 80 by 80, respectively, are available, what would be the best glass plate to be used in the experiment? Give reasons for not selecting the other two plates, right? The best one. Think of the dimensions. Think of the dimensions. 5 and 5 means that's a very small one. Then that would not be enough to stop exhale layer, right? And 20 by 20 is ideal. 20 by 20 is ideal, right? And 80 by 80 is too large that it not enable us to stir this, right? 80 by 80 can we stir this using hand like this by 80 by 80? No, that's too large. That's too large, right? Always you have to keep stirring the system. Then the best one is 20 by 20. Then what is it? M, ne? Right? Best plate M. M. M means 20 by 20. M. 20 by 20. Reasons for not selecting other two plates. Right? First one. 20 by 20 is too small. 20 by 20 is too small. Then it would not be sufficient. It would not be enough to stop all exhale air. Right? For L, first let's write. For L, not enough area. Not enough area to stop all exhale air. Not enough area to stop all exhale air. And for not selecting N, too large, too large, too large. Hence, the system is difficult to stir. System is difficult to stir, right? Too large. Hence, it's more difficult. It's more difficult to stir the system. Right? It's more difficult to stir the system. It's more difficult to stir the system. Right? That's a common sense question. That's a small kind of a modified thinking part given. Common sense. Common sense. Right? H. Because in the experiment we discuss about the size as well. In the experiment also we discuss. Now the dimensions are given. Right? H. In the seminar also I discussed about the size. Right? H. In the experiment, the average value of the dew point and laboratory temperature are found to be 26 and 30. 26 and 30 respectively. Determine the relative humidity of air in the laboratory using the graphs given in figure 2. Graph given in figure 2. In the graph, x-axis gives the laboratory temperature and y-axis gives the dew point. In the figure, straight lines represent the different relative humidity values of 100 degrees Celsius, 90 and 80, etc. Okay. Relative humidity. Okay. Then, now dew point is determined. That's 26. And room temperature is known. Then get the intersection here. See? Get the intersection. This is 26. 26 කියන මෙන්න මේ line එක. 26 is here. Right. See, 26 again. 26 is here. Oh, sorry, this one. 26 is here. Right, this one. 26. Right. Should be a little bit above. Right. 26. Then from the other axis, right, from the other axis, room temperature, laboratory temperature 30. And 30 will to which line it is going to intersect? Right? See? Then see, it is intersecting at this point the line with 80, which means relative humidity is 80%. Relative humidity is 80%. Right? Use a ruler and check it out. Right? Some are rulers on it now if the grid is clear enough. If the grid is clear enough, rulers on a good. That's it. Right. That's it for that question. Any doubts, any clarifications needed before we move on?